Oh, I haven't gone live yet. Let me go. All right, we're going live. Do you see? Are we good? All right. Hello and welcome everyone to this brand new episode of Corecast. I am your host, Tim. Oh wait, what? One thought. Forgot about the audio output. 1 second. Okay, can you do a sound check? Sahil, say something.
Yeah, you sound fine.
Oh, okay. Now it's good because you guys were muted before. Okay.
Oh, I was muted. Okay.
Yeah. Okay. Let's do one quick intro. Okay, quick, so that I'll edit it out. All right.
Okay, sounds good.
Okay. Hello and welcome to this brand new episode of Corecast. I am Tim, your host.
Now, Mikey.
And this is Sahil. Welcome everybody. To a brand new exciting episode of Quirkcast. If you haven't already joined our Discord channel, please do join it so you can ask us questions there. And if you're watching this on YouTube, where we do this every Tuesday, 5 p.m. Pacific, 8 p.m. Eastern, do ask us questions during the episode so we can get to them as well. So without further ado, let's get to it. So Tim, last time we talked about the direction of time and these different directions, starting with the uh, the psychological notion of time, the electromagnetic, the entropic increasing direction of time. And if you haven't checked out that episode, check out our previous episode to figure out what we're actually talking about in more detail. And so in continuing with this theme of time, I thought we could just discuss, like, can we go backwards in time? Like there's this notion of it like moving like one direction inevitably, but can we actually go backwards? And so I'm gonna put you on the spot.
Yeah, and in fact, this intriguing possibility came from Stephen Hawking's original paper back in the 1989 or so, and he alluded to this possibility when he described these four notions of time that Sahil was just laying out. The one notion of time that we have not described was the cosmological notion of time. This is the idea that because of the Big Bang, the universe go from small to large, right? And if you look at the entropy calculation, you see that hey, in the beginning of the Big Bang, the universe was in a state of very low entropy, even though the like we mentioned before, the definition of entropy isn't so well defined, but we can pretty much argue that every measure of entropy will yield something that's significantly smaller, right? Then Stephen Hawking postulated this interesting thought experiment. He argued that what if we live in a universe where instead of the universe getting bigger, what if the universe gets smaller, right? We kind of have imagine like a reverse of the Big Bang scenario. And then in the paper, he postulated that in that scenario, entropy would decrease, and that perhaps for people living in that universe, time will at some point, well, time will go forward in the beginning, but at some point it will start to go backward. So that's kind of what initiated this discussion. So the question is that real or is that not real? Such a possibility.
And what do you mean like backwards? Like if I imagine like a movie playing where it expands and then contracts, there's still this like feeling that I'm still moving in one direction, time just bounce back, kind of like a rubber band. When I expand it and let it go, it comes back. But I don't say it's like playing backwards in time.
Yeah, but I would say that if imagine you're running on a computer, like you're trying to play, I don't know, universe simulator, right? And
Mhm.
then you're trying to select all the different universes, and the ones that you end up playing with are the ones that actually has low entropy at the end, right? Like instead of trying, so the universe that we live in now, it's kind of like imagine there was some, I don't know, omnipresent being were to choose a simulation, like, oh, what kind of simulation do we choose? I don't know, like one of those Netflix original movies, right? But it seems like that whatever that being was choosing like a initial condition that had low entropy, right? But imagine the being as opposed to making that choice, it's making a choice at the end of time, right? Imagine that being was to do that, then he or she, when they play that universe, we will see um effects like, like a maybe like light, instead of being emanating from the sun, it will actually go toward the sun. And indeed, as opposed to plates getting broken, it will get unbroken, and maybe people will get reborn, unborn, and all that. So it's not totally insane if you think of that possibility.
Seems pretty crazy to me. I don't know.
I
Yeah,
was just about to say the same thing, Mikey.
yeah. I mean, look, I'm certainly not advocating for it, right? But I'm just pointing out that in that original paper, Stephen Hawking did postulate that possibility. But if we were to suspend our belief system and think that, let's say this were to happen, right? Then would we perceive time as going backward, or will we not perceive time as going backward? If we follow Stephen Hawking's 4 arrow of time, it would mean that, cosmologically, the universe is going backward. The universe is shrinking, but the entropy is decreasing. So the entropic arrow of time will be flipped. And using the same argument as before, we will argue that the electrodynamic, arrow of time, the fact that the sun shines as opposed to unshining, that will be reversed. And that also means that the psychological time, because our brain sends signal out as opposed to the signal getting unsent, right? That will also be reversed. So if that were true, actually, we wouldn't feel the universe any differently. We will, because all the arrows of time will be flipped except the cosmological one. Then we'll still feel, probably perceive that time goes forward, because we will only remember things in the future as opposed to things in the past. And it will just be a choice of language, right? The future will be the past will be the future. We'll probably just call the past the future the past. It's a little confusing, but you know what I mean.
I actually, Mikey, I'm curious. Like, what do you make out of all this? Like, this sounds kind of gnarly to me. Like,
Yeah,
what
no,
would you think?
I just want to, I guess I'm trying to think of a question to ask. And I think the question that I'm kind of like zeroing in on is like, so I'm imagining a universe, let's say, so, the fact that entropy tends to increase, like, and on a macroscopic scales, that plays into how we live our lives, right? It's the reason why resources are scarce, because when you extract energy from resources, you're left with decay, waste products, basically. That's so. If I imagine a universe that's kind of similar to the one we have right now, but just that one aspect was reversed, are you saying that that kind of universe is like that can't happen?
In principle, that can happen, right?
No, wait, are you saying it can't happen or it can happen?
Oh, that you mean a universe where waste energy gets converted into useful energy?
Yeah.
Yeah, I mean, I would say theoretically that's not forbidden, right?
Isn't
It's
it?
Yeah, well, I mean, we can go through that. There's actually a theorem that can be proved to some extent that says theoretically it's not totally forbidden. It would just be a really rare universe. It would
Oh,
be,
yeah. Okay.
Wait, okay, can we take a step back? Can we explain to the audience what useful and like non-useful energy means? Like energy is energy, right? What do you mean by useful and non-useful? Mikey, go. You look excited. Look great.
Um, yeah, I mean, so I guess I would say useful energy is ordered energy, and waste energy is disordered energy. So oftentimes we think, in school, high school, we learn about the energy cycle, the quote unquote energy cycle, where the sun, shines rays on the earth. Um, and then we absorb the energy, plants absorb the energy, and then we eat the plants, blah, blah, blah. And, energy is cycled through. But you can also think of like an order cycle, right, where the beams of energy that come from the sun are highly ordered, and plants absorb this highly ordered energy, and they radiate this very low frequency disordered energy. So we're basically sucking order from the sun, and these engines only go one way in these kinds of universes, right? It's the reason why you can't have perpetual motion machines. So just the idea that resources become more useless with time is deeply tied to the idea that entropy is increasing in our universe.
That makes sense. That makes sense. So if I'm understanding this correctly, your question was, typically in our universe, processes are usually one way where they convert useful energy, this like direct energy from the sun, into more of useless waste energy, as so called, because you can't extract anything from it anymore. And so your question is, can that go backwards in a universe that goes backwards in time?
Yeah.
Yeah.
Yeah, and putting it in the language of because we don't, well, personally I don't necessarily like the order disorder phrase, which is almost, it almost sounds like it makes sense colloquially, but it's really like a technical term in physics. We can frame it in terms of possibilities, right? Because the sunlight coming from the sun kind of hasn't explored all the possibilities yet. That's why we can kind of bottle it up and kind of allow it to go through the different possibilities for the future, and that creates useful energy. And that's literally, it's synonymous to exactly what Mikey was saying, and we call that orderly because all the possibility has not been explored yet. And when all the possibilities explore, it's sort of analogous to imagining you're bottling. Let's say you're putting a bunch of gas in a bottle, really high pressure, right? The gas molecule hasn't explored the room yet. So if you release it slowly, you can direct where those gas molecules will go. You can directly toward one. You can directly in the bathroom or the living room, right? You get to choose, right? But the moment the gas molecules are all escape into the entire house, you don't have that choice anymore. And this choice is why, we can choose the kind of work that we use the energy to do. And the question really is, this opportunity comes naturally because of the error of time, right? Because in the beginning we have more opportunities, and at the end we have less opportunities, right? So if that were to reverse, right? Imagine for a moment that can be reversed, right? It would kind of mean that for example, imagine that the molecules in the room were in the next 10 minutes suddenly will regather into the bathroom, right? That's what we're talking about. If time were to go backward, right? That would mean that the molecule in our room has to be in a very particular configurations for that to happen. And then I might, like, for example, the position of my finger cannot even deviate a tiny bit for that to happen. Because if I deviate it, the whole shebang will mess up. And that will kind of feel like, and if that really were to happen, it will basically feel like, I think, we will lose agency. That the universe will have to happen in that one particular configuration, and in such a way that all the air molecules will go to one area backward in time. And I think that, I guess that would kind of feel like going backward in time, right? It's just like, you don't have a choice. You're going backward. Like, what happened kind of already happened in a way. So it's kind of...
Are you saying that if time goes backwards, then destiny exists, but if it doesn't go backwards, then it doesn't exist? Is that what it sounds like that's what you're saying.
Yeah, in some sense. Well, but to some extent, if it goes backward, then it already happened, because like, you will know, right? You kind of will have a feeling that, hey, you know what? From all these molecular patterns, if you were smart enough, you determine that, hey, that molecule is gonna go to the room, and it's almost gonna be like you remembered it, in some ways.
No, but we're not smart enough. No, I mean, it wouldn't be like that. Like, you could say the same thing about, our universe. Like, oh, if you're smart enough, you could just, extrapolate all the trajectories, and then, but the point is, we wouldn't be able to do that.
Yeah.
So
No, of course. Of course, yeah. I'm not suggesting that we can do it, but I'm saying that for a universe where time flows backward, we have to be able to do it because that's the only way time can flow backward. And indeed, I think going back, Stephen Hawking's original paper, in the paper itself, he actually corrected it himself. He actually mentioned that he was wrong. Actually,
Huh.
he mentioned that his colleague pointed out some flaws in his argument, and that even if the universe were to contract back again, and it turns out that entropy doesn't necessarily have to decrease. I think that's the more modern understanding now. That increase of entropy actually doesn't need to be exactly the same as having a small universe. So
I think the modern
Wait,
understanding is that like it's not true that whatever Stephen Hawking says is true. He actually is known for like betting on things that are unlikely to be true and championing things that are unlikely to be true. Um, so it's weird when we see like these news articles that are like, oh, like Stephen Hawking, said this, and then everyone, people assume that like everyone just assumes that's true, but it's actually the opposite. um, if
yeah,
Stephen Hawking says something is true, you have to, be very, very skeptical. Is he just fooling
yeah,
around or?
yeah. But I would say it's fair. Like I mean, sure. I mean, sure he was wrong. I mean, we probably shouldn't give him too much criticism either because we know like really prominent physicists have been wrong, and the thing about it is that usually many of them are very open about it. They're like, oh, I was wrong. Great, I realized that I was wrong. So it's just I guess this is just a little bit of a difference between how physicists view some of these ideas versus the general public view these physics ideas. So
It's possible that Stephen Hawking is wrong more often than most other physicists, just because he's known for championing ideas that are
a little
kind
bit,
of wacky and unlikely to be true.
possibly a little bit. I mean that's one of the reasons why he is more popularly known. He chases more outlandish idea. It's a matter of style, I suppose.
yeah. So coming back to this, I guess for going backwards in time, um, you mentioned that he said that he was wrong about like being able to go backward. Oh, about entropy. Actually, can you explain the part about entropy? Like entropy not going down as the universe shrinks. It
Yeah,
sounds very counterintuitive.
yeah, exactly. So he thought originally that if we kind of have like an anti Big Bang, basically like a backward Big Bang, which is plausible if a universe shrinks, um, then everything will go backward. But he was wrong basically because uh, so entropy is counting the possibilities. Possibilities could doesn't just come from the expansion of the universe. I think this is a more modern understanding now. The universe expand or contract, that's not the only thing that dictates what we call entropy. Things like black hole production, star getting extinguished, and all these more intricate physics dynamics also contribute to entropy. And also, there's a modern understanding that entropy doesn't necessarily always have to go up, actually. And particularly when you take quantum physics into account, this notion of entropy is a little less defined now because entropy, as we argue, it has to do with possibilities, and in order for you to count possibilities actually have to be possibilities, right? Like, for example, if you roll a die, you're not going to count the possibility of 7. You're not going to get 7, right? So when you count the possibility in the beginning of the universe, how should you really count it? Like when the universe was small, should we count the possibility that it could be a particular size? Like, not all possibilities are created equal. So one has to be a little careful counting these entropies, and that makes the discussion a little tricky. So anyway, just having a small universe and also low entropy, it's not necessarily enough to explain the error of time that we observe. I think that's the more modern understanding. There needs to be more.
I see. So what you're saying is that the entropic direction of time is not enough to explain like time going backwards or forwards.
Yeah, exactly. Well, in our universe, it works, but in some other imaginary universe, like toy universes, it might not work like that. You could have universes where entropy goes down, goes up, and time kind of goes differently. At least not the way we see it. So physicists have cooked up these toy universes.
Yeah. Actually, I wanted to ask you, uh, going to pop culture, there are a lot of movies that talk about like going back in time and like, like Back to the Future, and a bunch of other movies. We don't necessarily have to, reveal what the plot lines are to spoil it, but can you comment on that? Like, is that truly going backwards in time? Like, is that can we actually do something like that? Like, get into a time machine and just go like back to the ancient Greeks or like whatever.
Yeah, I think we should kind of like distinguish like, so in the beginning you kind of you posed a question about going backwards in time.
Hmm.
But I think what Tim is really talking about is like, can you reverse the direction of time? And that's different, right? So if you
Hmm.
wanted to go backwards in time, you can possibly make a wormhole that connects to some earlier point in time, and like Back to the
Hmm.
Future, you could end up there, and then given your general opinion on things like the grandfather paradox and how those things are resolved, you could cook up something that would, check the box of going backwards in time.
Hmm.
But really, what we're talking about here thus far has been reversing time, right?
Yeah, I think that's a slightly different concept, right? Like movies only portray you go to a point earlier in time, but yet you still go forward in time. It's almost like you hop on a train, but then visit some other point in time, right? But it's not really like all of a sudden things start going backward. So I think these are two distinct concepts.
Two movies have
Uh,
tackled it. Two movies have tackled it: Tenet and Benjamin Button. Those are the two movies that have tackled what we're talking about today.
makes sense, makes sense. I guess then like, how do we know that like time right now is not going backwards and we happen to call it the future? Like
Isn't
how
that what defines what we call the psychological era?
Yeah, I
Like
thought.
whatever we experience the cycle that defines the psychological era.
Yeah, I think that distinction is just an artifact, right? Like we could call forward in time backward. That's totally fine. I mean, in terms of physics, you know, physics treats both directions the same, and
Mhm.
it's just up to us to decide which way forward, which way backward. Of course, contingent on um, the what we call the boundary condition. Actually, we do have to cover the question. Maybe that gets lost. Like, there is a reason why we even care about this question at all, right? It's
Mhm.
and
Yeah, what?
yeah, it's
Oh, go ahead,
because
Tim.
there's a theorem that says the laws of physics should apply the same forward in time and backward in time with an asterisk, right? And this is called the
Mhm.
CPT theorem, and it's a very celebrated theorem that can be proved actually using very basic assumptions of the laws of physics. Um, so that's I think where some of the conundrum comes from. Like some of these hypotheticals come from. Like our theories should in principle support going forward or backward in time. But the question is why is there experimental discrepancy almost that we don't see it?
Wait, sorry, I'm embarrassed to ask this. How do you prove CPT again? Is it related to spin statistics or?
Yeah, it is related to spin statistics. I mean, personally, I don't know the details either. But there's a yeah. I mean, a few assumption is that this if the universe has a certain amount of symmetry, which we believe to be true, and then that particles had these behaviors related to their spin, which we're not going to go into. These are very technical arguments about symmetry, and that the universe is local, and by that it means that the interaction has to happen at the same location in space and time.
Wait, I
Um,
don't think we should get into this detail right now. I just want to, so like, if someone talks about a CPT violating theory, that's would you automatically nonsense, right?
yeah, basically, it's a
Okay.
mathematical statement. Yeah, if someone
Okay.
comes in and tell me, be like, hey,
Yeah.
this theory cannot go backward in time. I'll be like, you screwed up. Sorry, try again.
So that's really the crux of it then. That's yeah. This weird fact about the universe that it happens to be
Yeah, but
manifesting time reversal invariant.
Yeah, actually, you hit upon something interesting. So, laws of physics or physical theories say that things can go backwards in time and forward in time, yet us macroscopically perceive a direction of time. And so, I guess, like, how would you actually, Tim, how would you construct an experiment to be able to tell if you're going backwards in time relative to the direction that we're moving forwards in?
yeah, I mean that's a very good question, and in some sense, you actually cannot construct an experiment. Let me quantify that a little bit. Like if everything is going, let's say, backward in time, then still all the arrows of time will still align, and we will just call forward backward and backward forward. So nothing would change, and you cannot experimentally distinguish this. So the arrow of time itself is not a problem, right? The question is why is this direction so consistent? Why don't we see my hand going forward in time and my left hand goes forward in time and my right hand goes backward in time, right? That's really the discrepancy there. Like if the laws of physics apply equally forward and backward, how come we don't see separate isolated systems kind of have slightly different directions of time, right? So that's the only thing that's experimentally testable. Or actually, there's a third possibility, right? It's somewhat related, right? We're basically saying that in order to test this, we need to have systems where one goes forward in time, one goes backward in time. That could happen on a small scale, or that could happen in the grand scale. If we live in the multiverse, if physics applies equally forward and backward, then meaning that quantum mechanically, if there's a possibility of forward in time, there should be a part of some kind of a universe possibility that goes backward in time, because it has to be kind of symmetrical. So whether that's observable or not, it's probably debatable, right? And then you can argue, is this physics? Is it not physics? Can it be falsified? Can it not be falsified? So
I see. So one other thing I wanted to ask about, either you or Mikey, is about antiparticles. So I remember hearing from Richard Feynman, or rather quotes from him, or his study of his modeling of antiparticles as regular particles traveling backwards in time, or particles traveling backward in time. So my question is, like, if we were in a universe made of antiparticles, would we be going backwards in time, but actually calling it forwards?
That's the CPT thing.
yeah,
So you could describe our universe as a universe of particles moving forwards in times, or as a collection of antiparticles moving backwards in time. But that's not backwards or forwards in terms of any like strict sense. Like literally, it's a relative forwards or backwards with respect to the calculation you're doing, right? It doesn't. It's not indicative of any.
yeah, it's
Yeah.
literally.
It doesn't. It's not related to one of these four. Is it?
I
Not
mean,
related to one of these four.
yeah, I mean, mathematically, you're literally, whenever you see the time t, you just put a negative sign in front of it. It tells you that every calculation will be similar. Of course, you interpret it differently. So, yeah, like Mikey was saying, like when we see an antiparticle, we can think of it as an antiparticle or an ordinary particle moving backward in time. Both perspectives are valid to the extent that's how you read the equation. So you could argue that, look, there are some particles just moving backward in time already. But
said another way. Oh crap! I had a thought. Crap! I forgot.
We can hold that thought, but
All good. So we are almost at time. So I wanted to give you guys a chance to answer the question we came in with: can time flow backwards? and leave any thoughts you have with the audience.
Yeah, I would say
Go
that
ahead.
in light of the CPT theorem, I would say yes, because this question is almost a matter of convention a little bit. Because you could
Mhm.
just add a negative sign in front of time in every single equation, and because of the CPT theorem, you can be like, well, let me just pretend all the particles are antiparticles. And the reason we need that is because, complex number, you add a sign in front of time, it's this, and then you can compensate that by adding a negative sign in imaginary, numbers, but ignoring all that. But then it tells you that the overwhelming flow of time, you can reverse it. It doesn't do anything. It's just purely conventional, right? So it's not really an interesting discussion. The real meat of the discussion is, can we have time that flows forward and backward at the same time, right? Like two systems that flow both forward or backward, forward and backward. And experimentally, we haven't really seen this. Like, we have seen it in a very contrived, like, engineer system, but naturally, we don't see this. So from that regard, we can rule that out. Like, our theory does not support, like, my left hand moving forward in time, my right hand moving backward in time, whatever that means. There needs to be some force, if you can call it that kind of coherently create this overwhelming sense of forward in time. And Stephen Hawking kind of tells you why is because the boundary condition, yada yada yada. So that's not totally unexplained. But the key question I think now is that, are there systems that are really far apart where one moves forward and one moves backward, like multiple universes? And that is unsolved. We actually don't know. Maybe our universe supports that. Or maybe our universe does not support that. Like, I think different physicists has taken different viewpoints and come up with different theoretical models that explore some of those. But personally, I can't tell you which one is the preference for me. But question mark. Maybe not. So
Mikey, what do you think?
Yeah, I guess the way I'd summarize it is, so when we talk about time, like as in space, you can talk about relative time. So relative time is always reversible. Just depends on whether or not you mean, you're starting from plus 10 or minus 10. You can just flip a minus sign. And the question about the arrow of time, these thought experiments deal with some kind of like overall notion of time. Like, you can track time by how big the universe is getting if you assume it's getting bigger. And I don't know, I think this conversation doesn't leave me that satisfied, because I feel like the real mystery here is the psychological arrow of time. Like, why is the psychological arrow of time aligned with the one in which entropy is increasing? And I don't know, maybe that's not a physics question. Yeah, I'm not sure.
Well, Mikey, we would refer you to our previous episode.
Yeah, all the answers are there. All the
I would hope so.
Well, I think we explained some of it from the perspective of electromagnetism, but of course, if you want to dig into consciousness, like, why does this conscious feeling of time arises, I think that requires something else, right? It's like then we're talking about, like, how the emergence of consciousness, which I don't think we can quite get into as physicists. So
yeah. I think, yeah, the explanation of boundary conditions is not quite satisfying to me. I just think there's more to talk about with this. Yeah, that's all.
Yeah.
So we'll
Well
see.
then, Mikey, future episode in the
Yeah,
works now.
we definitely should
You
circle
heard it.
back to this.
You heard it, folks. All right then. Well, I want to thank everybody for joining us, and we'll see you all next week.
yeah, see you all next week.